All right, welcome everybody to the last lecture of the Econ module. It will be about the economics of Polkadot. So we are shifting gears a little bit from these other lectures that were focusing on purely economic concepts to actually look into how these maybe translate to Polkadot or which different aspects Polkadot has in that regard. If you're less familiar with Polkadot, don't worry. There will be, these concepts will be reiterated on during the PBA, and you can always revisit the slides and, get a better understanding then. Also, don't worry to ask if some of the core things are not clear to you. I can try to briefly explain them, but we will still, stay on the surface here. And also beware, I did last night some small changes, especially to numbers, and updated them. So your slides might not be fully updated to my slides, but I will push the changes later today or tomorrow. But overall, the slides should be fine. Okay, let's take a short overview. We will be looking at which economic pieces build the Polkadot network, what are their mechanisms and incentives, and also how are those pieces interrelated. Also, as a remark, we are currently, as you probably know, in a phase of change with Polkadot. There are a lot of changes planned, a lot of changes being worked on, but I try to highlight that during the lecture and tell you where things are going. So when we look at the economic puzzle of Polkadot, we can make out a few economic pieces here. So the first one would be tokenomics, right? So some information about the dot token and the inflation model. Then staking. Polkadot uses a nominated stake of proof of stake algorithm, which is called NPOS. And this is also used to foster decentralization. Then the treasury is a very important part of Polkadot because it contributes to the maintenance and evolution of the network. And then, of course, parachains are a key component that, on the economic side, compete for slots on Polkadot, and they incur opportunity costs for being in Polkadot, which we'll see also. Then there's the slot auction. We talked about them yesterday, the candle auctions. They are, as I said, going to be less important, probably, because there will be a new model introduced with the bulk markets and the instantaneous markets. So we won't be focusing on that too much here. And then also bridges are quite the important factor, which we will also skip since it's a little bit out of scope, but I'm sure during the PBA you will have lectures on that one. So let's first look into the token economics. So Polkadot has the dot token, that is the native token of the Polkadot network, and one dot is denoted in 1 E10 planks. A plank is actually the smallest unit of a count, and this is a reference to the Planck length, which is the smallest possible distance in physics. And I believe there's also Planck time, which is the smallest possible time unit in the universe. So there's a little homage there. It is a utility token with several use cases. You can use it for governance, to foster decentralization, to change the direction of the networks going in. Then generally you can bond it in slot auctions right now, so this gives it the utility. Later on, when we change the model, this doesn't change too much. You basically use dot token to get core time or to get capacity in the Polkadot network. And then you can also use the dot token for staking, which provides the economic security of the network. And then, of course, you can use also dot token for message passing or signing extrinsics, for example, transfers. So let's look at the inflation model that Polkadot has. Inflation is simply the expansion in token supply. So there's new tokens coming into the network. And they are actually minted from thin air, right? That is inflation. They come from thin air. And they are used right now to pay staking rewards for validators and nominators. And validators, for those that don't know, as a high concept, are just the nodes that secure the network, that make sure that the network is running. And you need to compensate them, of course, for their work. You know, there's computer hardware costs, but also you will see later that you need to make them economically secure so they have no incentive to actually screw up the network, right? And this is why you need to pay them. And then you have the nominators, on the other hand, that are just token holders, can be anybody, and they are, through the nominated proof of stake system, responsible of selecting which actually of these validators become the active ones. But we will see that also. The inflation model right now also is used indirectly to fund the treasury, because I will denote that on the next few slides, but if there's some inefficiency in the model, underlying model, some of the funds that should go to validators and nominators are actually directed towards the treasury and fund the treasury. Why that is the case, we will see. There's a central economic variable of the model, or there are a few of them, and they are exogenous, like they come from the outside, right? This is not something that we, for example, could choose. And that is the staking rate, which is the total amount of staked dot divided by the total amount of available dots. And as you see, this is exogenous, right? Like, you can try to influence that, of course, but it's just how it happens to be. Then you have some endogenous variables, and we use the optimal staking rate, as it is called, that gives a sufficient backing to validators and to provide reasonable security. That is basically our idea, or like it was at the beginning, but now, of course, it's governance. The idea of how many DOT tokens should be staked to give reasonable security. And we will see that the inflation model is anchored around that number. The total inflation rate is always 10% per year. Questions? Yeah.
It's a good explanation. Can we get maybe like also a higher level definition of inflation model, and why is it required, necessary?
Okay, so
like
the definition of inflation is,
model.
Okay, so the definition of inflation is basically like expansion in token supply, right? There's new tokens coming in, and it is very convenient to use that to incentivize validators and nominators.
Like, my point is, for example, I mean, in Bitcoin, there's a deflation model, right? Like, basically
not really. I mean, now it's
total supply is cut.
Well, yeah, but still there's new Bitcoin coming into the network every day, right?
True, yeah.
So Bitcoin is actually inflationary, at the beginning at least, but the inflation is reduced over time. It's
saturated over time.
Yeah. I mean, if you look at the beginning of Bitcoin, I think Bitcoin had a huge inflation,
right? Of course,
yeah. But so the difference you're referring to is that in Bitcoin, we know that there will be an end. And here we have the total inflation rate of 10%. But this is only the current snapshot of the system, and it has always been like this. But Polkadot, being governance-driven, doesn't mean that this will stay at 10%. And we will also talk a little bit about that.
Okay, maybe my question is like, so in traditional fiat banking, you have like the central banks setting the inflation rate.
Yeah.
So in this context, like, this is how the inflation rate is set, given that there's no central bank.
Yes. So here, basically, the code sets the inflation rate, and the network was incepted with 10%. And it has always been like this. but it might change in the future. This is not a variable that is unchangeable.
But is it like a single variable, like there's a piece of code somewhere, and the inflation rate equals 10, or is it derived of all of this?
Yeah, that's a good question. So actually this is, right now, this is a little bit cumbersome to change. You need to make a runtime upgrade for this, but we are currently, or like some Parity devs are currently working on a way to expose this parameter directly to governance, and then governance can, with a referendum, change that number. And of course, once the Parity devs worked on the code change, then again, governance the community need to accept these changes, and then it's much more easy to access this variable.
Okay, but my question...
I think this goes a little bit too far, right? Okay. Maybe you can talk with me after. I don't want to go too much into runtime upgrades here, because I'm not sure whether everybody...
Just a quick question. This 10% per year?
Yeah.
And why and how today the staking rewards are higher than this? Like,
we will come to that. You will see. How do we derive ideal staking rate? It is actually like eyeballing. Yeah, there's like no perfect concept. Like there's no theory behind it. It's just like we will see that we have different modes of the token, and like back in the days, it was decided that we want to have roughly 50 to 60%. Yeah.
My question is...
If it's short, I can just quickly repeat it.
The question is, the inflation rate is 10%, but it's actually based on activity. It's like how much token get lended. It's based on how many transactions, I guess, because it's used to pay staking rewards. So
No.
Oh.
The 10% is fixed. There's no other tokens entering the system. The transaction fees are paid by the dots that are already there.
So I guess my question is, if there's no transaction, how can that be minted from thin air? Or,
If there's
or does it depend on the number of transactions so that
No.
for each? Okay.
Let's continue.
Sure.
This is not the only slide on it. There will be some more. So let's look a little bit more closely into the inflation model. There are different states of DOT. Right? The DOT can be liquid in a way. There you can transfer it. You can use it for message passing. You can use it to provide liquidity in markets. Then DOT can be bonded in staking. And this is the economic mass that guarantees the security of the network, because you're backing that, and in the later slides we will see why. And then for now, you can bond them in parachains, which is actually where the demand for DOT, where one piece of demand from DOT comes from, that parachain teams need to compete in these auctions, buy the DOT, and then use them to bond them in the market, in the parachain slot auctions, and then actually get the right to participate in the network. And here the goal is to obtain some sensible ratio between those three states. And then that is where the ideal staking rate comes from. It is, like how do we basically, so at the beginning, before the network was incepted, the question was like how the ratio between those metrics should be. And for example, you want to have some liquid tokens, of course, because outside markets need to function. They need to have liquidity. Then, of course, for staking, you need to have a sufficient security in the network. And then you also want to have some of the token being bonded, because that is where the main demand will be coming from. So let's look at the inflation model here. So on the y-axis, we have the percentage. On the x-axis, we have the staking rate. And we have a black line here at 10%, which I said, it's just an indicator. Here, we will always have 10%. I mean, right now, we have per year 10%. And in green, we can see the yearly interest rate in staking, and in blue, the inflation to stakers. And that is actually answering your question, because, for example, here, in the optimum where the ideal staking rate is equal, or the staking rate is equal to the ideal staking rate, which is right now around 57% or 59.3%. So when we are in the ideal situation, all the rewards go to stakers. 10% inflation goes to the stakers. And you ask, why is the API higher? And the simple reason is because it is not 100% of the token that get the 10% of staking rewards, right? It's only 59.3% that get the whole 10% of inflation. And then, of course, it means that the API is higher, right? Because less token get all the inflation, and then we're around like 16.7%. And the whole system is designed in a way that actually we want to push the staking rate towards the ideal staking rate, right? We want to give some incentive that the staking rate converges to the ideal staking rate. And how that is done is by reducing the inflation that goes to stakers when we're not in the ideal. And as you remember before, I said we always have 10% inflation, right? So we are not lowering inflation to do that. But the idea here is that the discrepancy between the ideal rate and like this area here will then be diverted to treasury. So we want to keep a 10% fixed inflation, but we want to give stakers less if they are not in the ideal situation. So we need to do something with the surplus, right? Because we want to stick with 10% inflation. So what has been chosen is to give this amount to treasury. Can you use the mic?
So in this example, the percentage, like the graph that we have, so the staking reward that we decrease if the result is not ideal that we want the percentage. So is it for an individual, or like how do we see this? Like,
No, that's on an aggregated level.
On aggregate,
Yeah, you look
to
at
promote the whole system towards more staking.
You look at the whole system, and you want, if you have all the dots that exist, you want to have 59.3% of them staked. And why this number is, I will say in a minute. But we have some, and yeah, maybe ideal staking rate is not the best term. Let's say targeted. I mean, it is like how it is in the code, but maybe targeted staking rate would have been the better term.
So everything else on that actions that will happen, like transactions or whatever will happen, is from the remaining 40% amount only. Like whether is it treasury proposals or whatever.
The 59.3% of dots, they are staked and they are bonded and they cannot be used for message passing. You cannot send them away. Yeah.
Okay.
Yeah. More questions over there?
I have a question. How does the treasury get funded if the ideal rate is lower than the staking rate is lower than 59%? Because you said like all of the inflation goes in that case to the validators, like the stakers.
No, actually not. Like your question makes sense, but you have a little error. You should say that what happens to the treasury if the staking rate is exactly the ideal staking rate.
Oh, so in both cases,
in both cases the treasury gets something.
Oh.
If it's not exactly the same, then the treasury gets something. But your question makes a lot of sense, and we will talk about that later. If the ideal staking rate is exactly the staking rate, if the staking rate is exactly the ideal staking rate, then the treasury gets nothing. That might be a problem, but we will talk about that.
Okay.
I'm a bit confused between the green and the blue one.
Okay, so the blue one is the inflation rate that goes to stakers.
Okay, but you said that the inflation rate is fixed. It's the black one, right?
Yeah, it is the inflation rate that goes to stakers. The rest of it this difference here to the 10%, this goes to treasury.
Okay, and the green one.
The green one is the API for stakers, the staking rewards percentage.
Okay.
And why this is higher is that, let's say you're in the ideal situation, you have 10% of staking rewards, but you give those 10% to only 59.3% of the people. This is why this API goes up.
Okay, but then doesn't that mean that they will want to be less stakers to get more? Like,
but not collectively, because you can see that the API is the kind of the pressure goes into that direction where both things are coinciding.
But so if I understand correctly, if we have 10% stakers, they will take 30% of the APR, right?
Sorry, if we have 10% of stakers?
If we have 10% stakers,
yeah,
right? The green is around 30.
Yeah.
What does this 30 mean exactly in this case?
That's the API that these 10% of people get. But the problem is it is incentivizing other people to join in.
Ah.
Yeah.
Okay. Yeah.
Okay, more questions over there? Okay, good, perfect.
So would it be fair to say that the difference in the black line and the green line is the extra rewards that stakers are earning for, because it's only 59%?
You mean the blue line?
Yeah, sorry.
Yeah, exactly. That goes to treasury.
Oh, that goes to treasury.
The
green.
difference. The difference.
No. I'm talking about the green to the
green to the black.
Yeah.
That's just the difference in APY, yeah.
Okay.
Yeah.
Michael. Mikael.
Yeah, okay. Yeah, that's for sure.
I'm sorry, I think I'm not the only one. I don't understand like the terminology here. Like yearly interest rate in staking, inflation stakers doesn't compute for me like as a term. So I don't really understand anything here.
Sorry. So what?
Like
blue is the inflation, the part of the inflation that goes to stakers.
So the part of the inflation that goes to stakers.
Yeah. And the green one is the yearly interest rate from staking for those that are in the staking system.
Okay, so given a X amount of coins, tokens going into the pool, the inflation stake, the blue number is a percentage of those that is the reward for staking.
Okay, let me maybe explain it a different way. So the inflation is calculated, the 10% is calculated on all the dots that exist.
Yes.
But then this number is only distributed to the 59% of people. This is why the API goes up.
Why API also? I think I'm confused by the term API.
That is the yield staking, like the percentage of, like if you stake one dot, at the end you have one dot plus 15 point.
Okay, it's just for us engineers. API.
Sorry. Yeah, it's good. Sorry if I confuse you.
So
yeah.
API is.
It is interest rate.
Okay.
Something like this. Yeah.
Yeah.
And I think that what I said before makes it clearer. So the inflation rate is computed on all the dots that exist.
Yeah.
And then this amount, this 10%, is only given to 59.3% of the people.
Okay.
So that is why the API is
Yeah. So at first, if there are less stakers, the rewards are higher, but then they are getting less. If you interpret the graph, and the difference, it goes to the treasury, right? But then if the ideal staking rate is reached by the stakers, it means like the treasury gets nothing, right?
Yeah.
Okay.
We will talk about that.
Okay.
Good observation. Very good observation.
Hello.
Yeah.
Johan here. One question. I don't understand if these graphics are the natural movement or are only the ideal movement because the API that you get when you are staking depends on validators and
Yeah.
in the ecosystem itself. So, and beside, the 10% is something that is decided between the community by governance or something like that,
Yeah.
or where is this coming from?
So generally speaking, everything is decided by community governance, right? Like you can change every piece of code through governance. This graph depicts the situation in the case of an ideal staking rate of 59.3%. Because this is here the ideal spot. If the ideal staking rate changes, and that is actually what I want to say here, the ideal staking rate is kind of flexible. It moves around and it scales with the number of parachains. And then this graph would like move around. And so the ideal staking rate decreases with by 0.5% with more parachains. And that is the reason why we wanted to keep this ratio. If there are more parachains, then we need to allow for more tokens being bonded for parachains. If there are more bonded tokens for parachains, then we can expect less to have in this staking system.
Okay.
But then if we have 120 more parachains,
There's a minimum. I think the minimum is 40% ideal staking rate. Okay. Yeah. If you're interested. No, not this one. Oh, here. So, I don't know if that makes sense to go into now. Maybe should we do it later? Yeah, yeah. Okay. Or maybe, yeah, you can also talk to me later. But is it roughly clear? I don't want to just you don't understand it and I keep continue. I mean, this is probably the most tricky part of this lecture, don't worry. No, that is derived by how much inflation goes to the people. So the green line is the result of this situation here, in a way. It's issued daily, but it is issued daily such that if you extrapolate it to 1 year, it's 10%. Right? Like it's a fraction per day, and if you accumulate all the rewards over 1 year, you get roughly 10%. Okay, let me...
Can I try explaining the graph?
Okay, yeah, sure.
Okay, so ignore the green curve. Just look at the 0.01 horizontal line and the blue curve. Everything below the blue curve is what goes to stakers. Everything above the blue curve, but not higher than 0.1, goes to the treasury. So you can see, and then the green curve is on an individual basis. So you can see how as there's more people staking, the APY, your yield for the amount of DOT you have staked, goes down because the staking rate increases, and it decreases exponentially past the optimal staking rate. So
yeah,
you need to kind of look at the green curve and the blue curve on an individual basis. So 0.6 is the optimal one, and it just drops really fast. And then before that, you can see how it works.
Okay. Yeah. Thank you. Okay. I see a lot more people with happy faces. Good.
I have a question. Can I ask?
Yes. Where?
Over here, Rish here, this side. So, what would happen to this model when basically the parachain auctions are gone and the go time comes into the play? Will this be still valid, or there's going to be change in the model?
The question is, so I mean, if that happens, the model wouldn't change at all. The question is, do we want to change it? Does the community want to change it? Because there might be other ways that are more interesting to do that. But here, the way of how core time is allocated doesn't influence this at all. Like not technically, like not, there's no mechanism that is interlinked here.
Yeah, but with the parachain auctions gone, a lot of DOT will automatically come into the like open market because
Yeah,
basically parachains are holding a lot of DOTs locked for
Yeah.
2 years.
Yeah.
And with that going away, will that increase the kind of the supply
no.
suddenly?
So what would, and what is a thing to solve is if we don't have parachains anymore, the question is how do we scale the ideal staking rate? But there might be, governance, like the community might just decide to just put a fixed point and say the ideal staking rate should be 60%. But let's not go into too much details here because I want to have everybody on board that this roughly makes sense.
Yeah.
But I think that we are getting there, right?
Yeah. Staking reward goes to parachain bonded tokens as well or not?
To what? To
There are two types of bonding. One is parachain bonded tokens. Tokens bonded for being a
yeah.
parachain.
No, they are not staking. The tokens that are bonded in parachain, these auctions, they are not creating staking rewards.
Not rewarding it.
Yeah.
And you said minimum
Ideal staking rate
is
is
40%.
40%.
How do you ensure that? I mean, it's up to the people. They stake or
Yeah,
not.
yeah, but this mechanism should ensure that, right? Like there's an incentive to converge towards the ideal staking rate, and it's actually here it's the incentive is quite high, and here it's kind of linear. But we can see that there is enough incentive. Like I wouldn't be afraid that we diverge too much.
Okay, thank you.
So the difference between the blue and green, who does it go to?
There's no. So again, the green line is just an indicator about the API that the yield of those people that are in the staking system. So if you have one dot in the staking system and you are in this situation, your one dot has a yield of 16 point whatever %. If we are in this ideal staking rate scenario, but we are here, then your one dot will have this yield. And we are in 0. Let's say 95% inflation, and the rest of it goes to treasury. Okay, good. One more?
Can you just demonstrate what will happen if the active parachain will increase by 1? Just to show how that shifts.
Yes. Then it would be 0.8,
Yeah,
8.
just to demonstrate how
And
the
then
green
you
line
would,
reflects on the blue line.
you would basically need to go here to 8.8, and then you actually, since this is not exactly at 1 anymore, you need to rescale the ideal staking, the ideal inflation, the API, such that the quotient of this, if you divide those two, they need to get to 0.1. And then this whole thing moves a little bit to the side. Okay.
Thank you.
Yeah, if there's more question, feel free to come to me later. Let's say it one more time. So we have a fixed inflation of 10% per year. 10% of new tokens come into the network every year. And this 10% is calculated based on all the dots. But all the dots are then distributed to only the stakers. And in that situation, we have, for example, if we are assuming that 59% of people are actually staking, and we have an ideal staking rate of 59%, we would be in this situation. So 10% of tokens go only to 59% of the people. So the dots in the system have a bigger weight, right? They are weighted by 1 over this 59%. So you get more rewards. Like, okay, you got it? Oh, very good. Nice. Okay, let's continue. So we talked a lot about inflation. In the fiat world, inflation has a negative connotation. And this is a general discussion in economics. There's just different opinions, I guess. My take is this: especially predictable maximum inflation is kind of good, right? It's okay, at least. It incentivizes to work with the token. So you actually want, I mean, it's a utility token, right? You want the people to use the token. You don't want to have it as a store of value where people are just like hoarding the token and not using it. It is kind of the oil of the system, and you don't want nobody to give it away. You want to have a well-oiled system in a way. So in my opinion, positive inflation is definitely good. The question is 10% good? Maybe it's too high. I don't think it's too low, but there are some people arguing that it's too high, and there will be community discussions about that. So I think a lot of the problems come from the fact that the market is somewhat planning with some certain, so outside of Polkadot, right? Like in the real world, there's some people are planning with a specific inflation, and then by some things like war or something, the inflation just jumps completely up, and this screws everything over. So I don't think it's a huge difference between 2% or 3%, as long as you know it stays there, and then the whole market can basically adjust to it, right? But if it's 2% in one year and 10% in the other year, and then it jumps around too much, it creates issues that the markets cannot adjust properly. Well, I mean, for example, in Polkadot, you have it rather predictable because it's in the code. And actually, to change that is not easy. It can be changed, but probably it will be taking a lot of community effort to change it, which is good, right? Because you want to have, you don't want to switch it around every half year. There's something in economics, at least in like Keynesian economics, people are disputing whether that's true, but it kind of makes sense that deflation can cause a halt of economic activity because people start hoarding the token, because you assume that the token is more worth next year, and simply by deflation, so nobody is actually wanting to buy anything or use it today, and since everybody's waiting, then the economic activity halts. So there might be some, yeah.
So I wanted to ask about this, a little bit of inflation is good attitude. So I definitely understand and agree that you're saying, like, if there's a little inflation, people will use their token and spend it, and if there's negative inflation, then they'll just hoard it. Totally agree with that. My question is about the value statement that that's good. I want you to think about why it's good that people use their token and move it around more. Because one way you could see it is that causes more like fossil fuel burning, more deforestation, more stress in people's lives. So why do you think that that's better than if people kind of just held their tokens and didn't do so much and all of that kind of stuff?
I mean, in the example you are giving, it would be like terrible for everybody if we stopped using electricity or like going around, right? I mean, I think the question is the underlying things that you do with the goods. They need to be good, right? And I think what you're a little bit more referring to is kind of overconsumption, right? Like if it's too much, then of course it's bad. But like you want to have some activity, right? Like on Polkadot, you want to sign extrinsics, and you want to sign messages, XCM messages, and this shouldn't get too expensive, right? Sorry, he has the mic.
Yeah, so thanks for your answer. I wanted to say, I guess, like, people do have motivations and incentives to do things already. Like, I have a motivation to like buy or grow some food because otherwise I'll die, and like I don't know, like go out and socialize because otherwise I'll be lonely and stuff. And so I guess my question is like, those incentives alone have worked for millions of years. Why do we now need to incentivize more consumption? Why do we need additionally inflation? And
Yeah,
also, I'll be done after this.
I mean that's a good question. It's very hard to answer, I guess, because we don't have a lot of experience about situations without inflation, I would say. I think what could be like kind of a middle ground is to have a little bit of inflation, right? To give a little bit incentive not to hoard the things, but also not like have 20% inflation. So you try to consume everything today and like you know. I'm sorry if I think there is no perfect answer here, right? It's like always, yeah.
Hi, Sukmeet here. So there are two things that I wanted to mention. First, inflation, the definition that we saw earlier was, let's say if there are 100 dots in the world in 2023, there will be 110 in 2024, right? So it's not the same as inflation in real world, because where that means is the price. It's not like if somebody has $100, like US government has $100 minted, then they're going to make $110. Inflation just means the same amount of money will still be there, but these goods will cost more. And that's just one point, right?
But I think also traditionally it means there's more money around, right?
No.
Inflation. What do you mean?
Like it just means
it's an expansion of also fiat currencies. More cash, huh?
the value of the money has gone down, so it's
Yeah, but why does the value go down? Because there's more money around, right?
They may not have printed more.
I mean, I don't know if there's like, if you're referring to other things. I mean, there can be shocks in productivity, of course. Like if the chip industry burns up, then chips just cost more without having more money. That's for sure. But like traditionally, also inflation means you can achieve inflation by expanding the money supply, of course.
I'm not saying that way. What I'm saying is, let's say COVID, inflation hit, the food prices went up and stuff, right? Like money was not printed more unless until...
As far as I know, it was.
It was afterwards to... You're right, like... Yeah. Right? Like it was printed afterwards to give away, okay, we have trillions of dollars of debt, let's print more money. But what I'm trying to say, it's not 10%, like 6% inflation or 2% or 3% is correlated to a GDP, right, of a country. So...
I mean, you have different effects. That's for sure. Like, for example, let's say there's 10% inflation, but whatever that measure is, like the usefulness of the network goes up by 20%. Then the token can be worth more after inflation than before. That's for sure. But we are here always assuming, like in these kind of scenarios, you're assuming what is called like ceteris paribus, which means that you keep everything constant, and if you only look, if you keep the whole world constant, but you have 10% more tokens, then the tokens must be 10% less worth.
Yeah, hello. So I wanted to just make a comment, I guess. Also take a little bit issue with the idea that mild inflation is always good, because yeah, that is kind of the sort of traditional way of seeing it. I don't know, maybe some of you read the book The Price of Tomorrow by Jeff Booth, and I think he makes a very compelling argument for a deflationary monetary system. I think his core argument here is that technology is a deflationary force, right? If you think about it, like things, technology improves over time. Technology never gets worse, right? Technology always improves, and therefore, over time, it becomes easier to produce services and goods, right? Now, even with the AI, this is like really accelerating. But even with anything else, with agriculture, right, it's much easier to produce one ton of grain now than it was like 10 years ago, 100 years ago, right? So therefore, since it becomes easier with technology to produce goods and services, like the logical thing would actually be that the same basket becomes cheaper, right? And we see it with like many other things, with computers, right, that do become cheaper and more powerful over time. So actually, that kind of contradicts the idea that we need inflation to keep the economy going. And I guess like sort of his argument is that the reason why we do have inflation is because of the expansion of the monetary supply, right? Because of central bank policy, and that only benefits a select few, right? I.e. those who are closest to government, right? The cronies of the government, like who are well connected, the bankers, like state-owned enterprises, these kind of people.
Okay, yeah, I like this idea a lot. That's true. That could be true. That like even in a deflationary, like with 0% inflation, you would have deflationary or like things get cheaper. That doesn't necessarily say that like a low inflation is bad, because it might make it a little bit more cheaper even on top, but it wouldn't break the system, right? And then I mean the other part that you said about corruptive system, that's I guess true in reality. The nice thing about something like this application is that it's very transparent, right? Like if you're a staker, you're part of the system, and if like there's no hidden movement of funds here. Like you see everything, and if you're part of the staking system, you get part of the inflation. Yeah.
So 10% inflation, can I say per year? So is it like same 10 by 365 per day? Or
so yeah, no, it's you get the staking rewards per day, but it's like if you extrapolate these everyday rewards to 1 year, then you're at 16.8% or whatever.
So every day it's same. It happens
Yeah,
every
you don't
day.
get every day 16%, of course.
Okay.
That would be crazy.
Got it.
You get every day 16% over 365.
And in this design consideration, as you said, you prefer liquidity over the hoarding.
No, I didn't say that we prefer liquidity over holding. I said that in the system you need liquidity and you need the holding.
You're both. Okay. Yeah. Okay. Makes sense. Thank you.
Okay. I think one more. Okay. I think it will never. The question will never stop. So I have to stop it. Sorry.
Thank you. Okay. Just adopt inflation. I think it's good at least at this point of technology. For example, in Polkadot, inflation is good because the ecosystem provides technology, right? That's a big differentiator for the inflation, right?
Yeah.
But in the fiat world, inflation is bad because you can't put all the people at the same level, right? At the same basic human development of level. So for inflation be good on a fiat system through technology, as the colleague said, every people should be secured with I think a basic human development, right? That's my assumption. I don't know how everybody could see this.
Yeah. Okay. Thanks. All right. Then let's move on. Okay. So there are potential changes incoming. As I said, the current system incentivizes to move the staking rate to the ideal staking rate. But then, as some people figured it out, which is quite nice, the treasury inflow would be 0 dot. Right? And I don't think that this is very sustainable, right? It worked very nicely in the past, but I think over time, it doesn't make sense to incentivize a situation where the treasury doesn't get any inflow, because the treasury has become such an important part of the ecosystem and such an important driver of the ecosystem that we need to make sure that the treasury has always enough funds to fund their operations, right? And I did propose some changes to actually detach the inflation to stakers from the total inflation and divert some fixed amount of the inflation directly to the treasury. Let's say we have 10% of inflation and we get 2% of it to treasury, and then we have the same graph, but we scale it to the 8%, right? We don't have to look at the graph here, it's just a rescaling. But basically, the idea is let's let's mint some fixed amount of inflation to the treasury, and the rest we can use for stakers. And this actually is I think I linked it also, I hope I linked it, if not I will. There's some discussion in the forum where I proposed this change. There was a lot of discussion about that. And yeah, this change is just a proposition. It needs to go through governance, and every token holder can decide whether they like that or not. And of course, if you are a token holder, you can also decide that.
You mentioned like a good point of view about inflation, and I was wondering like if the difference between the ultrasound money model that Ethereum has adopted, what is like the difference, and is that worse than this inflation vision, or if they're better? I mean, which situation one is better than others?
Yeah, it's very hard to tell. We will find out. One thing that I found myself in is that, I mean, the fees are quite high. I don't like. It's just a different approach. It's very hard to tell what is right or wrong. But I think in the sense of Polkadot, the notion that DOT should be a utility token kind of hints to the fact that it's fine to have some inflation here. But yeah, I mean, if you have different opinions and want to change the inflation to 0, you can do a proposal and discuss this with the whole ecosystem, have a vote on it, and then we will see.
Regarding price rise, just assume suddenly utility or some activity in the ecosystem grows drastically and inflation is constant.
Yeah.
So based upon that, the price of the transaction will rise definitely.
Yeah, the question is, yeah, as I said before, let's assume there's some godly given notion of usefulness. And it's very hard to, like, it's very hard to compute, but let's say everything stays the same. We have 10% inflation, but the DOT token becomes 20% more useful. Then the price would still go up, right?
And we expect that?
I mean, you should, yeah, of course. I'm very hopeful for Polkadot.
That's why we are here.
That's why we're here. That's why we actually educate you guys to found and develop nice projects. Yeah. Okay, somebody's tapping on the microphone. I'm
here.
Over here? Okay. I wanted to say I'm not going to let you because of this, but you are actually raising your hands for quite a while. So.
Yeah, I have. I'm being polite, guys. Come on. I just want to get some like intuition behind it, because I mean, at least when I first heard about Polkadot, I think back in 2015, 2016, very early on, and I later found out about the economics. I think my intuition for the inflation made sense, just given that historically speaking, and that people are aware of this, Ethereum launched as a system where the actual tokens were highly centralized. So particular folks within the ecosystem own more than like 40 to 60% of the tokens. And early on, there's a concern over takeovers of networks and so forth. So I was wondering if the intuition for inflation also came from that, so that we don't have sort of these agents at the beginning that can take over the network itself.
So one problem is that I wasn't around to the time where this model was designed. So I don't know what the idea was. But I think what is what you're hinting at is quite important. A kind of nice thought that, in inflation, maybe it makes sense to change it over time. Maybe it makes sense to start the network in the first 2 years with 10% inflation, and maybe at some point it makes sense to change that.
Okay, yeah. Thanks.
I think I should go on, guys.
I think one thing that we're...
I think I'm going on.
Okay.
But I'm around for a few more days, so you can come to me. Okay, let's go on. Staking. Let's talk about staking, the concept. So we are using the nominated proof of stake algorithm, and we give economic incentives to validators and nominators, and we align them to those of the network, right? The network wants to keep running. The network wants that everybody's using the correct code and is not trying to hack something. And in that sense, good behavior is rewarded with staking rewards, right? Like validators that do their job, they get staking rewards. And I think that is something that maybe hasn't become clear in the previous discussion, that you need to pay validators to do their job, and you also need to pay them to be secure. And that is a very big benefit of inflation, right? Because you know exactly how much you're kind of paying them within like some boundaries. If you think of a situation where you have no inflation, then you need to come up with some way to pay them, right? And maybe this is highly fluctuating. Maybe maybe you could scale it with transaction fees, but then what happens if transaction fees for some reason go down quite a lot? Then the validators become very insecure, and they might be open to collude to wreck the system, right? So, and with having a fixed inflation, you kind of circumvent this problem by actually being able to predict and change the rewards to them. Malicious and neglecting behavior is punished. We call that slashing. So whenever, and you will see that I'm sure throughout the course, whenever some validator finds out that another validator is misbehaving, then their bonded tokens, they cannot access their tokens, they can be slashed, so being burned or being redirected to treasury basically. And this gives a very high incentive not to screw up, right? Currently, the minimum total stake of a validator is around 2.1 million dots, and you can kind of imagine what economic incentive is behind that. And the total stake in the system directly translates to the economic security that it provides, right? Like it's basically the backing of validators that give those validators economic security because they are always in the risk of being slashed. And an important factor here is that the total stake is pooled from validators, so that is when they have their own tokens, but also from nominators that delegate or nominate or delegate these tokens on behalf of validators. So that nominators are also part of this game, right? They want to select only nominators that they can trust, because if that validator is being punished or slashed, if they misbehave, then the nominator will also lose their stake. So the idea why we could, or the original designers could also say like, okay, we just have the validators needing their stake. But then the problem would be, okay, only a validator that has 2.1 million dots can be a validator. That's not very inclusive, right? That is like a lot of money, and then you would have like only big players in the system that can actually do that. And the idea of pooling the tokens of validators and nominators is leading to a higher degree of inclusion, right? You can start a validator with 1 dot, and if you have enough, make enough, if you're an important community member, if you're able to, excite people, find many friends, you can actually be a validator with 1 dot, which I think is quite cool. But it also has a high level of security. And the goal is basically to get as much skin in the game as possible, the validators. Yes, I think he was first, then you.
Thank you. Can we define the concept of validator and nominator, please?
Okay, yeah. So a validator is an entity, kind of a node, and they are running software. They are running the Polkadot software, and they are producing blocks. And they are responsible for the fact that they are proposing blocks, and the blocks should be valid, and then they get integrated into the blockchain. I hope that this is as high level as I can explain it, but I guess it makes sense. Nominators are just, they don't run their own software. They just decide which validator they want to delegate their dots to and increase their total stake. And if the total stake is high enough of a specific validator, then they become active. And they are actually allowed to produce blocks. You can be a validator and not have enough total stake, then you won't produce blocks. But your node is still running, right? You are still open and trying to find people until you get enough total stake. And don't worry, like all these concepts will be explained during the course. I think you had a question.
Yeah, so first of all, I just want everyone to know here that I am your friend and you're all my friends in the event that I do have one dot and can run a validator.
Can you what?
I can run a validator at some point.
You can run a validator now if you want. I think it doesn't take that long time.
You just said you need a lot of friends in the Polkadot ecosystem
Yeah.
to do that. I don't fully understand what that means, but that's the first
You
thing.
need to convince everybody to
Yeah.
delegate their dots to you.
Got it.
And if you are convincing enough,
Yes.
and you have 2.5 million, 2.1 million dots roughly, you will be active, and then your validator is producing blocks.
Great. And once I produce blocks, then what? So I'm producing
Then you
blocks.
get staking, like you get rewards.
Right.
I will see on some of the next slides how a validator is being compensated.
Okay, so the
And
point
then you're
is
part of the network, and then you produce blocks for the network.
Okay, so the point of this is like the more you create a tribe or the more dot you have or whatever, the more power you have for governance or whatever, or I don't even know, but for whatever, then we're gonna look at that.
Yeah?
Okay.
Yes?
Hello? Okay. So this might be more or less recap, but just to push in the point further on this. For those that are a little bit, at least, I guess the right word would be like hesitant on staking, since, well, obviously requires 2.1 million dots, and that could be an issue if you don't have enough dots. I'm just making sure here, double checking. Is it possible to more or less do like some sort of like staking pool where more or less you can have various other people contribute their amounts in dots more or less to add up to 2.1 million, and then the stake is split between everyone in the actual staking pool itself?
Yeah, we have staking pools. Exactly, that is what they are doing. Yeah.
All right. Yeah, I just want to make sure and just reiterate the point for a lot of people here who don't get the concept, more or less. So, all right, cool.
So I just did some calculation comparing Ethereum and DOT about the minimum total stake for validator. For Ethereum, you need 32 ETH, and it costs around I think 75,000 US$. So basically, it means a lot of people using their income, they can become a solo staker. But 2.1 million dots equal at the moment around 15 million US$. Is it? Do you think that this minimum level is too high or not?
I think you're confusing it. Like, you cannot just equate the whole consensus mechanism of Ethereum with that of Polkadot, and then like the validators in Ethereum are not the same as in Polkadot. They have different tasks. So I don't think it makes sense to do that calculation.
But for individuals, it's really, really hard to.
What you mean is that you're equating the validators of Ethereum with nominators here. Yeah, that's a good point. Yeah, that makes sense. Yeah, I mean, I guess Ethereum has some workarounds, but I'm not sure. But yeah, I mean, that's true. On Polkadot, you can basically stake with one dot, and in Ethereum, yeah, if you need the validator, yeah.
If I'm not mistaken, I think actually he did mean that, like, for staking, the minimum in Ethereum is 32 ETH, which is so and so, 75,000, whatever, and in here staking is 2.1 million. So the barrier for entry for staking seemingly is much higher in Polkadot. But I think, however, like actually by being a validator, you can stake. It's a bit like staking, I don't know, but like you could expose your ETH to staking reward, I guess.
Yeah.
And with a much lower barrier of entry. And the same is true for ETH. It's in a different way. It's like with different providers that basically, yeah, it's you pool staking, basically. I think maybe pool staking and validating is somehow similar.
Yeah. That was what I was hinting at. Like, we have this additional notion of being a nominator, right? That is the point. And you can basically have, you can enter the staking system in Polkadot with 1 dot. And he was making the point that you need the ETH. Yeah, with
pool staking.
Yeah. Okay, let's move on. So the question is, what makes validators more resilient? Sorry if I overgo you. So one of the things that make a validator more economically secure is the self-stake. Because that is basically the amount of dots that a validator is nominating themselves with. Right? So in that sense, a validator is the nominator of themselves, but they have it in the same account as the validator is. So we know for sure that these dots belong to that validator. And of course, the more dots that are there can be slashed, can be taken away. That means the more dots that are in there economically make the validator more secure, right? I hope that everybody agrees with that. Then there are also other things like reputation, identity. Many validators actually choose to disclose their identity, to say who they are. And there's this like social component in there, right? Like if a validator has an identity and then you know who that is actually, a bold statement that making it much more secure. I mean, ultimately people might fear for their life or something if they screw up, right? Like it's just more natural that if you know the validator, they have more incentive by social constructs not to screw up. And then a very important thing is higher future rewards. So with the self-stake, you also earn staking rewards, right? It's just like being as a nominator. But validators also have a commission. And that is basically what they charge their nominators for their services. And the higher the two things are, the more rewards they will earn in the future. And if they screw up today, they give up on all the future rewards. Right? That is something we talked about a little bit in the value of time, that if you screw up today, you don't get the few rewards in the future. And if the self-stake is higher and the commission is higher, it means the future rewards are higher. So all things being equal again, if you have a high commission, you don't want to screw up today compared to another one that maybe has a low commission. Now let's talk about the nominators. Those nominators, as I said, can be everybody with dots. They don't need to run any machine or something. And they can bond their tokens for up to 16 validators that they deem trustworthy. And as you remember before, I said that if a validator screws up and gets punished, then all their nominators are also getting punished. So the nominator actually wants to choose validators that they can trust. And this whole mechanism actually leads to the fact that we can be quite certain that the active validators, the validators that get enough backing, are actually good guys. And they, as I said, they have the incentive to find the best ones that match their preferences. And in a way, they are tasked collectively to curate the set of active validators, right? So we can assume that through the wisdom of the crowd, we can assume that those active validators are good. And when some validator is not good, we would say that they lose backing, they drop out, and a better one enters the network. Okay, let's talk about rewards. Andrew, maybe a little bit was Andrew, for you, the rewards. Okay, so how that works. As I said, tokens, the staking rewards are distributed among the validators in the network, right? So there are error points, and error points are basically just points that a validator gets for producing blocks. The more blocks they produce, the more points they have. Whether you can produce a block or not is determined randomly, and over time, every validator has the same chance of producing a block. So over a long period of time, you would assume that every validator has the same error points on average. But there might be differences within one error, just because of random noise, or because some validator has a better infrastructure, stronger hardware. So there's a total amount of error points per day, and then you have also a share of dots from the inflation per day that goes to these validators, right? Remember, if we sum up all the tokens per day that go to the validators, and let's assume we are in the ideal situation, then summing up all these tokens over 1 year would yield to 10% of total supply. So we have total amount of error points that were produced per day, and then we have the amount of dots that we have available to compensate the validators. Now every validator gets their share of the total error points. So let's say we have 2 validators, and one validator produced 60% of the blocks just by chance, random, and the other one 40%. So the validator that produced 60% of the blocks gets 60% of the rewards. The other one gets 40%. So then the rewards come in. The first thing that a validator does is taking out the commission. So if they have a 5% commission, they basically get 5% of this amount that they are getting. You have a question?
Yeah, so when you said 2 validators, 160, 140, just randomly. So as a validator producing blocks, and you saying it's random, is it just like as a validator we're like pushing to be picked, and then sometimes you're picked, sometimes you're not? The weight of that pick is random, and is it like based on some distribution? Like
so the distribution should be uniform. So it is really like a random function. If you have the same validators, the same 2 validators, and they are exactly the same, over, let's say, 30 days, they should have like almost the same error points. But it could be that, for example, how the consensus mechanism works is that one validator is allowed to produce a block, but maybe their hardware is not good, their internet connection drops, and we don't wait forever until they produce the block. But then another validator, we allow another validator to jump in and produce the block for them. And then basically it means that the error points go to this other validator. But that is, like on average, it should be the same, but within, like random functions within 1 day can have quite the volatility. Yes?
Just while you're on the commission step, are there any circumstances where they would forfeit their commission? For example, if they've been slashed or done something else that's naughty? So
if they have been slashed, they get kicked out of the system for at least for a bit.
And what recourse does the nominator have against a naughty validator?
No, none. Like if you have to make sure you put all the trust into that validator. And you need to make your homework. You need to know where he lives or where they live, and so on. Yeah, but the validator also loses their stake.
Do a lot of people in the Polkadot ecosystem know who the validators are, and like?
I would say so. Yeah.
Oh, that's so cool.
So what I wanted to say is and what is also an important part of my research, is that these dimensions are all trade-offs. For example, if I don't know who that validator is, but the validator is nominating themselves with 100,000 dots, then I might not even care who they are, because if they screw up, they lose so much money. But if a validator has 0.self-stake, I really want to know who that is. Because if I even don't know who that is, like I'm basically trusting a validator that has like very little economic incentive and no social incentive, and yeah. Okay, let's go here.
I had a quick question. So you mentioned that like the validators are randomly selected to produce the block, right? Are there chances for there to be collisions and like for there to be more than one validator that's selected, or is it?
I think so. I'm not an expert in the implementation, but I would say that there's some mechanism that prevents that. There's always one block producer chosen.
I have two questions. So when the validator gets slashed, do the denominators lose the entire stake or only a portion of it?
There are different slashes. Sometimes it's like 20% and 50%, and some slashes are for big offenses. When validators really screw up, it's 100%. And whatever the validator slash, the nominator is also slashed.
So it's passed through proportionally. And the other question, does the size of the stake also have a role in the randomness to being selected to produce the block?
No.
So that means...
That is a very important observation.
So that means as a nominator, I should pick validators who are close to the minimal threshold so I can get a bigger share of...
Exactly, yeah.
Okay, thanks.
Okay, let's reiterate. So, validators produce blocks and get error points that should be averaging out over time, but within one error it might not be. So then the total rewards for that error, for that period of time where we pay validators, are distributed relatively to the error points. Okay? Then the share of the rewards go to the validator, to the individual validators. The first thing that a validator does is to take out their individual commission. And they can set the commission between 0 and 100%. And nominators know the commission of the validators. So let's say this validator has 2% commission. The first thing that they do is take 2% off. Then what they do is they distribute the remaining amount to all their nominators. And here, a nominator is rewarded again proportionally to their amount of stake that they gave, that they delegated to the nominator, to the total stake of that nominator. And that leads to the fact that what the colleague said before, if the total stake is lower, the same amount of dots gets you a higher share in the rewards. As a little side note here, in that step, the validator is acting as their own nominator with their self-stake. So here again, they get a little bit for their self-stake. Does that make sense? So if we reach this point and we have two nominators, one with 60% and one with 40%, then this guy with 60% gets the rest of the tokens that are available here, and the other one is 40% gets 40%. Okay, let's say we have 100 dots coming in, and or let's say we have 200 dots as rewards for the whole era. And this guy produced, there's two guys, this guy produced 50%, or it doesn't matter. This guy produced 50% of the error points. Then, what did I even say? 200 dots, right? So 100 dots coming in here. Then he has a 1% commission. The first thing that he does is taking out 1%, 1 dot. Keeps it. That's then he has 99 dots. Then it goes on, and he looks like, how many, like different nominators do I have? Yeah. And let's say they have like 2 nominators, 50-50, and then the 2 nominators get 50% of 99. Yeah. Yeah.
Can I ask?
So does it mean that if I'm a big validator with a lot of the dots, it actually makes sense for me to, for example, if I have 2 million dots, I should run 2 validator so that instead of 1 instant?
So with 2 million dot, you would be unlikely that you get in both, right? Let's say you have 4 million dots, then it makes sense.
So
to,
as much as I can split, it actually makes sense to split more validator, right?
So what I want to briefly mention that the NPOS mechanism, it doesn't mean that if you have 2.1 million dot that you're for sure elected. There's some election process that is quite elaborate, but it is leading to this minimum stake. But if you have a lot of dots, you can make it so that you get elected several times. And yes, if you have enough dots, it makes sense to have multiple validators because then you can have a bigger share in the active set.
So in this commission model where the validator is basically setting up one commission as soon as they first got the reward, like minor question was the ERA thing, like what is it? Is it different from different parachains? But the major question is that when the commission, the validator node, now it comes to the individual node where first they'll take the cut and then give out to the their people. So because I'm not sure like how does that work? Does this also happen on chain? Because they might also not give 1%, they get 1%.
Okay, so of course this happens all on chain, and it's not like the validator gets all the dots and then decides to give it out or not. Right? So this is all like embedded into the code and on chain.
And
chain actually does that. The validator doesn't do that.
They can't change their own software, tweak their software to do it. Okay. This is also being verified by the network.
Yeah. Then actually the relay chain does that. Good question though.
And the ERA thing, like, is it different on parachains and why we call it an ERA? Like, is it not immediately the reward that?
ERA is a measure of time, and this is on the relay chain. Polkadot has it for 1 day. 1 ERA is 1 day, and I think Kusama has it for 6 hours. 1 ERA is 6 hours.
Okay. Last. So in this, like, why there's miners is another word which adds the block to the network, right?
Yeah, validators.
Where we call validators, which again, as you said, adds to the network and also others verify. So why we change this terminology from miners to validators? Because both of them are adding blocks.
I mean, the key difference is that miners, like with mining, you would associate a certain form of work.
Yeah.
You need mining sounds very tiring, right? And that is proof of work where they need to spend computational resources.
Right.
But there's no additional work to be done. They just need to validate the blocks.
Okay.
Or they produce the blocks and then the other ones are validated. Okay. You three. You already have to. Yeah.
Okay. The self-stake amount is considered in the commission, or it is in the...
No. The commission is the very first thing that they take out. So the self-stake is only part of the nominator. As I said before, a validator self-stake they are basically their own nominators. In this last step, they are basically their own nominators.
So they get percentage according to that as well.
Yeah, and their 1 dot is equal to every other's nominator's 1 dot.
Thank you. Can you talk a bit more about slashing? Because I'm not sure if I fully understand that concept yet, especially how severe it can get, right? Because it seems like, so it's not about the slashing is not just about the rewards, right? But it's actually about the stash, right? So if you have whatever, I as a nominator, if I nominate 100 dot, right, I can lose up to 100 dot, right? If the validator completely screws up. I mean, and I also feel if, for example, you said in theory, you can start a validator with 1 dot and then have 2 million dot from somebody else, delegated to you. In that case, that validator might be very lax at their, and then really screw up, and then literally those 2 million dot get slashed. So can you talk a bit through that? And actually, is that something that has happened in in the wild?
So fortunately, we haven't seen many slashes, and I think the few slashes that we saw were bugs. And Polkadot actually has the ability to, through a governance proposal, revert slashes. If it is super clear that it's a bug, right? It's not malicious behavior, but it's a bug, then we can revert it. But you're exactly right that all things being equal, a validator with more self-stake is just more secure than a validator with lower self-stake. What I wanted to also highlight is that higher commission, like all things being equal, the same validator, but one has higher commission, they are of course also more secure because they earn more money. And if they get slashed, they get kicked out of the system. So if I earn every day for the next 1 year more money, then I have more incentive not to get kicked out today than somebody that doesn't have that, right? The slashing can be between, slash means always bigger than 0, but it can go up to 100%. There are different offenses. I don't want to go too much into that, but let's say there's different degrees of slashing by severity, and it can easily go up to 100%.
And this 100% from the capital or just the rewards?
From the bonded amount, from the capital. So yeah, the nominators have a very strong incentive to find good validators, and the validators have very strong incentive not to screw up, and that's exactly what we want, right? We want to make it as painful as possible for every participant if they screw up, so we can be sure they don't. Let's go here, here, and then there.
So there are other blockchains that use different policy in proof of stake. Punishing the nominators, it's quite aggressive things to do. Other chain punish the validators if they act in a bad way.
Yeah.
So as a final user, I found difficult to research and trust on someone. It's very difficult for me to pick the nominator if I don't know them. So I really have to be extremely involved into the social context.
Not necessarily. I mean,
it's a war.
Maybe what you're referring to is reputation. Like, yeah, it might be difficult to find out who's actually a good guy by the name. But if you have no idea, and you should pick those with the highest self-stake. And that number is quite easy to find out, right?
Yeah,
you can sort by self-stake.
But pretend that you have slashed all of your amount instead of just slash the potential reward.
Well,
something.
Yeah, that makes it painful, so you really don't want to screw up.
I don't want to give money to you if I don't know you. Even if I know you, I don't want to give money to you.
Yeah,
but
then don't.
No, as an example of the scenario. But if you say, well, if I trust you, but I make a mistake, I lose the potential interest, why not? I give you a shot.
But what you're like lobbying for is to make the system much less secure, right? Like, I think if it's really painful, and you can, I see that you feel that it's really painful, this makes it on aggregate like very secure. I think the other networks, let's not talk too much about other networks, but what you could do is also say that, okay, we don't slash nominators, but then we wouldn't be able to allow validators to have 0 dot self-stake, right? So we would not be very inclusive, and we would say that, okay, validators need to bring the 2 million themselves, and we don't slash nominators. That would also be an option, but then we would say that, okay, only the very rich people can actually run validators, which we don't want. We want everybody to being able to run validators. Back there.
I am Risha. So my question concerns on centralization of validators. So someone there made a point that if I have 2.1 million dots, is it better to split up my nodes or to just put one node, right? So how does this system, the whole system of consensus mechanism, protects or prevents the aggregation of centralization of validators? Like someone, Giga Chad has maybe 20 million dots, right? And just has the all validators, and in every era just gets appointed one of these validators, and that can lead to even bigger issues, right? Because he the one controlling the whole validator set, like partial, like in a huge amount.
I mean, that's a general problem that every blockchain faces. You know, if you have like 20 million dots and you put those on all the validators, then there's also a case to be made that you are very invested into the system and actually don't want it to be screwed up, right? Because you are part of your tokens are bonded, and if you screw up, that you are actually losing more. Okay.
Excuse me.
Yes.
So, how do we know that there are, like, you know, you gave the 16, somebody can only have
between 0 and 16, yeah.
Between 0 and 16,
I mean,
right?
1
So
and 16.
how is it known that this guy has done, like, already passed his limit or not? Like, is there a way to identify on the Polkadot that this is the nominator, this is the validator?
You can aggregate all the choices of the people, of the nominators, and then run an algorithm that gives you the solution for the next round, which is actually what happens. So there's an election every day, and they take this as an input, all the choices from the nominators, and then they output the new set of validators for the next day. This is done every day.
And how can you, like, appoint yourself as a validator and let everybody know that I need 2.1 million dots?
Oh, everybody knows that.
How?
So you can be an inactive validator. You can be a validator and have everything set. The only thing that you need is enough backing to get in. And you can be for 1 year an inactive validator.
But how
your machine is running.
Let's say Jess there wants to be the validator with 2.1 million, and all she has, like us in PBA, which I don't have too many dots on us. So how does she make herself known to the community, being anonymous?
However you want. You can be starting here, talking to people. You can use the Polkadot forum. You can use Twitter, everything.
So is there like a
you can make personal calls. I'm not kidding. That is how it works.
So is there like a validator, known validator, who has come up with something like that and started
I think, yeah, most of them have their own strategy. Some of them work with having a lot of community work. They have their own websites. They have their own community calls. Look around and you will find a lot of them, which is actually quite nice, right?
Yeah, that's quite powerful.
Yeah, that's actually nice.
Like a short and technical question. Like, I'm still struggling a little bit to understand, like, why it's possible as a nominator to nominate more than one validators, right? I mean, if I have, like, you know, my dot, how is it possible that I can give it either to one person or to
Okay, that's
16
a good
person?
Yeah, that's a good question. It goes a little bit too much into detail, I would say, but you can select up to 16 validators. You can say that I trust all these validators equally, basically. Then the algorithm later decides where the dots should actually be allocated to.
So in short, it's to my advantage to select more than one.
You should get up to 16, because if you only vote for one and that validator by chance, or maybe they don't make it in, then of course you don't get any rewards. Okay, so what are validators being paid for? One obvious thing is, of course, hardware, networking, and maintenance cost. I mean, it takes, you know, effort to keep observing your node, to make sure to have like security systems that your node is not going offline and stuff. But of course, one very big point is resilience, right? You pay them so they do their job and they don't want to screw up. Nominators, what are you paying them for? You're paying them to curate the active set of validators, to take the risk of the validator and sort the good from the bad through some invisible hand mechanism. And that is, since it's risky, you could lose your stake. You need to be compensated for that. One question in front there.
Yeah, so I guess I'll make 2 points. One is that I'll give a shameless plug for Talisman. We actually run the largest nomination pool, but we actually
That's
have
how
to do...
that's how it goes. You see that?
With as little as 1 dot, I think everybody should at least try out staking if you haven't before. But we actually deal with that all of the time. So we have to choose our selection of 16 validators. We will interview them. We will see what their DevOps processes are. We will see if they have a backup server in case the one goes down. We will judge how well their networking setup is and what their bandwidth is, because all of these things lead to their ability to perform the validation. I think we will also look at their history. So you can actually see, the performance over time. It's open to everybody. It's either on the staking dashboard or somewhere else. It's very easy to see what the performance of validators are. And we will rotate them out if they're not performing. And so it's actually a very, it's quite an involved thing to find them, to know them, either through personal relationships or look at their on-chain reputation. And so, yeah, that's one of the things that we do. And I would say the second point is also important, I think, for the founders here. What you see a lot is that the validator, becoming a validator can actually be a very good monetization for your business. So a lot of time, if you produce a product, maybe...
A bit about more validator selection. So the job of nominators is to find and select suitable validators. And nominators face several trade-offs when selecting validators. You could say that there's security, performance, and decentralization. So we were discussing a few of those. And also, as I mentioned before, ideally those variables are also kind of, consistent over time. For example, the performance. Yeah?
Yeah, I was wondering, how can I start a validator if I don't have the money? Because I need to attract people. Suppose I'm a very good engineer, I know how to run the node, I have these credentials, but I don't have access to people with a lot of money. And I start running, but I can say, come here, but they're coming, and while we don't have the 2 million dots inside the validator, they won't get anything. And I don't know how long does it take to get to the 2 million.
So that's a good thing about NPOS. People, they don't only vote you, right? They don't only vote you, and you are not active, so they don't get anything. They can vote for a lot of active ones, but they can still give the backing to you by including you into the nominations. So it is quite cheap, let's say, for them to trust you in a way. Like, they still need to fully trust you, but to give you also the stake, it is for them rather cheap. Because if you don't make it into the active set, then the algorithm makes sure that they get with another validator in the active set.
Okay, so they choose as a group of validators they are in, and okay, I got it.
Yeah. Okay. So, the economic background, self-stake. One very important thing if you select a validator. That is the main indicator of skin in the game, right? Like, that is what a validator for sure loses when they get slashed. Higher commission. That is something that maybe not many people kind of know, or it's kind of obvious, but higher commission, ceteris paribus, means that, like, all things being equal, the same validator leaves a validator with more incentives to behave. Because if I earn today more, or if I have a high commission and I'm active, I earn more. So I really don't want to be slashed, because if I be slashed, then I don't earn that person very well, and there's like social contracts.
So still the question remains over that a new validator who is joining the network, he still has to build the reputation to attract the nominators first, right? So
Not
initially,
necessarily. I mean, if they have enough dots, they can just self-nominate and be in right away.
So like his question, he doesn't have enough dots, but he has all the technical aspects of expertise to run the validator, right?
Yes.
So to attract the nominators in that case, so what will take, because you need social reputation in the end, right? So to people trust you
Yes.
to nominate you,
Yes.
right? So is it a process, or are there any factors which are there supporting the validator that okay, nominators now they can trust the validators?
So the
What are the
Web3
criteria on that?
Yeah, the Web3 Foundation has a very cool program. It's called the 1000 Validator Program, is where they try to help people getting bootstrap, where basically you enter the program, you have to fulfill certain criteria, and then you earn trust points within the system, and then you get nominated by Web3 Foundation, and then get active. But that doesn't, like, that is just a bootstrap, but you still need to, like, get new people in, talk to people, ask them to nominate you, and that.
So it's kind of like it will take a couple of months or maybe some time to really build a reputation. Or
Yeah,
If
yeah,
keep
yeah.
keep nominated by the Web3 bootstrap program.
Yeah, exactly. So yeah, if you're interested, check out the 1000 Validator Program.
Just had a quick question. For the slash to value or stake, is it burned or is it sent to the treasury, or if it's like found
Yeah, the slash is going to treasury.
Treasury.
Okay, so efficient validator recommendation is actually one of my research topics, and I'm fortunate enough to, with colleagues, with great colleagues, to have published a paper in a quite nice journal about that, where we actually elicit the preferences of nominators on these different dimensions, right? Because that could be very individual. Like for some person, they are more interested in performance. Like they only vote for the best performing validators, and they don't care about economic security. Other people are a little bit more risk averse. They say that I don't care so much about performance, but I really want that one to be secure. And if you're interested, I can also link the paper. Maybe it's linked.
A quick question. So I understand your point on higher commission. Just make sure my understanding is right. Higher commission also means lower yield for the nominator, right? Because they take
Okay. Higher commission means lower reward for the nominator. So in a sense, you're basically, a nominator is paying in a way, or allowing the validator to get more share. And that of course means the validator is more secure because they get more money. There's the sweet spot, right? I mean, obviously, I guess you don't want to end up with a validator with 100% commission. But maybe you do. Maybe you just want to give all the money to the economic security. But I doubt that. But yeah, there's trade-offs. And that is actually part of the research. Let's talk about parachains. So what are parachains? Parachains, or now cores, are the layer 1 part of the protocol. These are these like independent blockchains that allows the scaling, and they dock onto Polkadot. They're blockchains on their own, and they run in parallel. They are highly domain specific. They have a high degree of flexibility in their architecture. And they use the same messaging standard to be interoperable, so they can all talk to each other, messages through the relay chain. And right now on Polkadot we have 50 parachain, on Kusama we have 46. And that state transition function, you don't need to know what that means, but it is registered on the relay chain. That actually makes it so that validators on the relay chain can actually validate the state transitions on the parachain without actually knowing the full state or the full history also of the parachain. And this simply means that we can scale, right? Because the validators on the relay chain, they don't need to know everything that happened on the parachain, but they still know that everything that happened on the parachain was fine. And then the parachains, they have collators, which is in a way their own validators. And they keep the parachain alive by basically proposing these blocks to the relay chain. And they are not needed for security because the relay chain actually knows what can be done on the parachain and what not. but they are kind of important to actually that somebody summarizes these transactions and propose them to the relay chain. So you will learn a lot more about this, but basically this is the overall idea. The thing is that they offer their utility to the network, right? Like the interesting stuff, the stuff that is meaningful, that is happening on the parachains. Like this is what makes Polkadot kind of useful. So the slots we talked about is basically a right to access the network, and they are kind of abstracted into this notion of slots. And right now, those slots are leases for 2 years on Polkadot and 1 year on Kusama. And of course, there's only a limited amount of slots available because you have networking issues, right? Like if you scale this to endless amount, like this is just not scalable. So this is kind of a scarce resource. Like we don't have limitless amount of resources, so we need to kind of find a way to actually allocate them efficiently. So we saw that yesterday. If you have some problem like this, you can run an auction and find out actually the market price of a slot, because that might also change over time. And the auction, and an auction is a very good way to do that. And for some reason that I mentioned yesterday, the candle auction. We chose the candle auction. So the tokens that are being used in the auctions are actually held trustlessly in custody on the relay chain, and they are not allowed to generate staking rewards, right? They are just kind of dead capital in a way. After the slot expires, they will be refunded to whoever gave them. So the tokens cannot be used for anything. They cannot be used for staking, for transacting. They are not liquid. They cannot be sold, and they cannot be used in governance, at least for now. That might change, but I'm not sure. But I guess it won't change because we are getting away from this thing. So that means, and you remember from the lectures the previous days, that these tokens are actually causing opportunity costs, right? You could use those tokens for a lot of other stuff, but you can't. So you're still, even though that you get the tokens back, you still have costs, right? You have the opportunity costs. One obvious opportunity cost would be staking. You could stake them instead of locking them for 2 years. But of course, there could be other things. You could sell the dots today and buy a car or whatever. Yeah, one approximation of how big the opportunity costs are could be the staking yield, right? And parachains need to compete with those costs to generate benefits that exceeds those opportunity costs, right? So there's this like some economic driver that actually says that if you're willing to lock up your tokens for 2 years, you have these opportunity costs. So whatever you do should be better than these costs, right? And this is kind of an economic incentive to actually have something useful. Like you don't just if you don't think that whatever you're doing is useful, you shouldn't be doing it. And that is actually some nice filtering process. Yeah, let's not talk about crowd loans. So. And also, once you have these slots, there needs to be sufficient economic activity to actually justify that you want to renew the slot. The slot mechanism creates constant demand for DOT token, right? Because these projects, basically, they need to buy the tokens or in some form aggregate the tokens to bid in the auction, and that is actually where the most of the demand comes from. And yeah, it is costly to be and remain scaling the security. Because basically security, economic security is a finite pie, a pie of limited size, because financial resources are limited. And every chain that secures itself needs to cut a piece of the cake, which leaves less to others, right? It's kind of a zero-sum game. Like if you imagine that everybody makes their own chain, then everybody needs to have the same amount of economic security to be happy, which actually reduces the amount available overall. But actually the shared security protocol allows to keep the cake the whole, because you basically concentrate the cake on the relay chain, and then you are able to or the parachains inherit this economic security to all parachains. So basically, shared security is a scaling the shards or 100 individual blockchains is less than you need to pay stakers to secure these 100 individual chains. So, as I mentioned before, there's some changes probably coming to this whole mechanism of how we allocate core time. It is based and introduced by Gav in his keynote at Polkadot Decoded 2023 and in RFC 1. I also linked the RFC in the notes. And it is somewhat a new narrative for the whole Polkadot ecosystem, where we basically want to move away from regarding parachains as a distinct entity, but rather regard Polkadot as a global distributed computer. And it's more spaces than apps rather than chains, but they are still remaining to be blockchains, mostly, I guess. And of course, producing your own blocks within that core. But this should be getting much more flexible, which is great. And then there's this notion of block space, where block space has different attributes, such as security, which is basically the scarcest resource in blockchain, and it's crucial in preventing consensus faults, 51 attacks that could compromise transactions. So whatever you put into the block, how secure is that? How secure is that message actually? And that's quite high for Polkadot. Availability, it ensures that block space is available without long waiting times or uncertain costs for a smooth and seamless interaction within the decentralized system. And it should be flexible, and this mostly comes from the fact that we allow very heterogeneous shards like these parachains, where the ability of block space to fine-tune by the consumer, so like whoever is consuming the block space, the core basically for specific use cases. So when we look at the block space ecosystem, a network collection of individual block space producers, these blockchains, these parachains, offering secured, fit-for-purpose, efficiently allocated and cost-effective block space. And that should be kind of the thing where we want to converge to with the new block space or core time system. Because what happened a little bit quite substantially with these 2-year leases is that basically the parachains obtained the right for 2 years to produce a block every 12 seconds, but most of them didn't need so much block space. It was like, let's say, it was highly inefficient to give this big amount of block space to parachains that actually can't fill this block space. And this is, the whole idea of this agile new way of allocating block space is to break up these inefficiencies and to be allowing a parachain, for example, if they see that they don't need that much block space, they can just sell it to somebody else that needs it. And yeah, the valuable aspect of this block space ecosystem is the connective tissue of shared security and composability, what I said before, that basically, Polkadot is providing this umbrella of security to all these participants. And the idea would be that dApp developers or block space providers can focus on their unique features and reusing existing capabilities within the ecosystem. For example, supply chain traceability application could use different types of block space for identity verification, asset tokenization, and source traceability. So, and how would that new market look like? It is still highly, it is subject to change, but there will be these bulk markets where around 75% of the cores are allocated to the market, and cores are sold for 4 weeks as NFTs by a broker chain. And the unrented cores, where basically these application and parachains can buy the core time, and unrented cores go to the instantaneous markets. So you, if you only need a core for a day or for even just one block, you can only just buy one block on the instantaneous market. Or if you buy a whole core for 4 weeks, you have the core for 4 weeks. The price is and increasing relative to demand. The final pricing functions, I think, are not yet finalized. And what is very important is that current tenants have a priority buy right for their cores. So if you are a project that has a core, you get a priority buy right for the next lease period of 4 weeks, which makes it very important for projects. Of course, they want to have some certainty of, I will be still around and I can actually pay for that. But of course, the price, if there's a lot of demand, that actually pushes up the price. So you have a priority buy right, but you still need to be useful to be able to pay that price in the future.
Can I ask a question?
Yeah.
Yeah. So I mean, so in this bulk markets, right, and this price finding mechanism, right, and just yesterday we said like auctions are still the most efficient way of allocating scarce resources, right? So yeah, even if we transition to core time, wouldn't it still make sense to have auctions for those cores?
Yeah, I think so. I actually did an RFC. I'm not sure the number. You can find it in the repo where I'm proposing some sort of small auction. I think it's a Dutch auction in a way for that, yeah. But if you look into the details, there's a lot of complexity there. I think also in the original proposal, there's some form of small auction. But then the price adjusts based on the final amount of cores being sold or not. So there's some auction phase, then cores are allocated, but if we find out that even through the auctions not all the cores are allocated, then we decrease some reference price or something. But yeah, if you're interested, check the repo out and check my RFC, where I'm also playing a little bit around with the reserve price that is actually moving up or down. Yeah. What happens with the 25%? Those go to the instantaneous market. They are available basically on the spot.
Hello, Johan here.
Yeah.
I have a question. It's randomly assigned the power of the computation of this virtual distributed computer geographically, or because one of the main problems and issues you get with distributed computing is that maybe you have a project here running in Asia, but if you have the validators in the opposite side of the globe, it could be very, very slow, no? So how does it work?
So I think Gav, in his keynote, I would highly advise you to check it out from Decoded. I think he has some numbers about computation power of the distributed computer and stuff. So, but I can't answer that now. Sorry.
Okay.
Yeah.
Hello. So my question, as a founder, I feel there is still a lot of uncertainty, like unknown parameters in this model. So what would be your advice? Should we wait? Should we try to build a parachain, even if we say the model is going to change? Should we wait for the core time and the bulk market, or should we use in-between solutions such as Tensy or stuff like that?
Yeah. Good question. I would say it depends on your risk profile. If you're super risk averse, maybe you want to try to win some of the remaining auctions. I don't know how the prices will look like. Maybe if a lot of people think that way, the prices will go up in the last auctions that we will see. Generally, I would not be too afraid of the price for core time at the beginning, because what we saw is that we have a lot of core time available and the demand is not that high right now. So I would assume that core time is quite affordable at the beginning and prices won't be that high. And actually the goal of Polkadot is not to make core time as expensive as possible. Like I'm always saying, we, but I'm not the one designing this, but like we as a community, I think we are more interested in getting more projects in. And not like maximize the revenue in these auctions or in these markets. So yeah, as I said, I can't give you any guarantee because it will be ultimately up to the market, but I would not be too afraid of like that you cannot afford core time at the beginning.
What about the ETA? When is
yeah,
gonna come?
good question. I think probably in Q1 of this year, I think it will be live on Kusama. But yeah, take it with a grain of salt. Who knows? And I'm also not the one developing it, so.
And
Core time, Q1, I think. But don't. I mean, I shouldn't say that on camera. But I think. Yeah.
And you mentioned earlier.
Look through some forum posts and like some GitHub issues, and you will find some vague things. It isn't far away.
And you mentioned earlier one benefit of that 2 year is because of the opportunity cost, so it filter out the really good application. But in a way, the changes here you're proposing is not having that, right? So
yeah, you have actually direct costs. So there's no bonding of tokens anymore. You just pay, and then the question is, where does the dot that you pay go? The original idea was to divert it to treasury. I actually made an RFC that I think it might make sense to burn the token to actually counter a bit the inflation. If you have the same or different opinion, go into the RFC GitHub and actually comment on my RFC and either say why it's good or why it's bad. But yeah, there's no opportunity cost in that way because there's just real cost. If you buy the core for 100 dot, you lose the 100 dot and it will go wherever. But that doesn't make it much, I mean, it's the same. You still have costs, it's not for free.
But in a way, that the good thing is then I can, I guess, trial it. So because my initial investment will be smaller than buying this 2 year thing.
Yeah, exactly. That is the whole, yeah.
But the quality may not be as good because some bad quality application can still try at a lower cost, and if it's not successful, then.
Yeah, but then it dies. I think what you should allow is like more of these weird applications trying, and maybe, I mean, one of them succeeds, right? And the other ones, and as I said, we have core time, we have enough core time. We want actually to have all you people try out crazy stuff and see what works and what doesn't.
Yeah, doesn't that put like a lot of pressure on parachains, on what would be parachains, to be profitable from the start? Because I mean, normally a business like takes time to be profitable, and if you don't have the capital initially, it's a thing to get like a crawl down and basically get that money for 2 years locked.
Yeah.
But it's another thing to ask users to pay for your core time directly.
But the core time will be much cheaper, like because you can have like divided by like a small time. So if you're a new project and you need a parachain slot for 2 years, you need more capital, right? So you also need to convince some people to give you that, and that doesn't matter. I mean, you are in the same situation. Either you're not profiter or you are, but that doesn't change much. Why is it easier to convince somebody to give you even more for 2 years if you're not profitable?
Yeah, because
I would actually say it's better like this, right? Like give a small loan and try.
No, yeah, I'm thinking more about the psychology of, okay, if this goes wrong, at least I get my initial capital in 2 years, which you are not getting
Yeah,
here.
but it's about opportunity costs. And like imagine like after 3 months your idea collapses, you don't get the dots back for another 1 year and 9 months, right? And you still have costs. Like even though you get your capital back, you have a lot of costs. And you might actually want to find out here after 4 weeks you can be free and like think about something else with all your capital. So I would say that's actually much better.
Yeah, not all your capital because you lost what you put into it, but
yeah. But like think about how much you lose in 1 year and 9 months. Think about the opportunity cost.
No, yeah, absolutely. Yeah, you're right. I mean, if cores are cheap, yeah, absolutely, this makes sense. But if cores end up being like quite expensive and like the staking reward you get while the opportunity cost is greater to put the money directly here, it might lead to less participation even instead of more.
Yeah. But let's say I think that I don't think that course will be that expensive at the beginning. Core time.
Yeah.
Yes.
I have a question. Can you give us your reasoning on why was the system still designed like this? These are mini auctions for 4 weeks, and why didn't you put the price on, let's say, the state transition function that the relay chain has to execute? Something like having a gas price on the work that the relay chain has to perform. So that would be more in the supply and demand realm, or?
I don't understand your question.
So
What does the state transition function have to do?
For a pirate chain, they're executing, producing blocks, and those blocks are getting validated by the relay chain, and the relay chain is performing and checking the state transition function. Does it hold some proof? So why isn't that process more on demand? Have a market for that instead of allocating, hey, here is 4 weeks, and you have 4 weeks to do it for free.
Okay, so basically, why have you been at the old model in the old times and now changing, right, in a way?
No, my question is, why isn't it more like Ethereum, because they're fully supply and demand? For instance, with rollups, the rollups batch many transactions on layer 2. The users pay for them, and the layer 1, in this case the relay chain, just performs one transaction, which is a state transition function.
Okay.
And based on current supply and demand of the gas price, that is the price of the shared security, on the current real-time price.
I think it's just a different model. We also have transaction fees, and they are dynamic in a way. But you're not putting that into a transaction, the function. It's just a different model that they are basically registered on the relay chain.
I get it, but in this case, for the 4 weeks, you can still have empty, I wouldn't say slots, but times where you're not using up your core.
Yeah, but you can sell them, right? If you know that, I mean, I don't know how the implementation will look like, but in the most flexible situation, you could, if you know that you won't use your core tomorrow, you could sell your core for tomorrow to somebody else, and then the next day you're back at your core.
Oh, I get it, but what was the reasoning of not going for a full supply and demand relation where you?
You mean only instantaneous markets?
Yes,
basically?
yes, yes.
Okay, yeah. I think that I'm not sure. I think there are some technical considerations here that the complexity of the system. Basically, it works better if you have some more fixed allocations. But I can't answer that because I think the reason is technical.
Okay.
Maybe somebody else, other instructors can answer that. Maybe over there she. Yeah.
So under this core time schema, so if I'm a dApp and application, should I buy this block space, or should I utilize the functionalities provided by other block spaces producers?
Yeah, I think that is a little bit like the question before. I think it depends on your application. Also technical nature. I think probably the technical hurdle to use some other blockchain provider to deploy your dApp might be lower than to build something from the ground up that actually uses cores. But that will depend on your application. And I think also that question could be answered by some more technical instructors better. Okay, let's actually go on. So why would we change that? And I have some interview with a customarian on Twitter where we are talking a little bit about that. So if you're interested, check it out. Where I say that basically, I think these auction models about the 2-year leases were quite good at the beginning of the network because it allowed these projects to build strong communities and to have a lot of certainty in the beginning. but now I think it makes sense to transition to something else. And the main idea is to lower the barrier of entry for people to simply deploy their code to a core and test stuff, right? I think, and there you should definitely watch the keynote of Gav, where he gives a little more background on that. It makes Blockspace much more efficient, as you remembered me saying that most of the parachains did not utilize all their block space that they got over the 2 years, which simply means that we are wasting block space, right? We want block space to be as efficiently distributed as possible, and one way to do it is to make it more fungible and more like smaller, and being able to make it more flexible and agile. All right. So let's talk about another important factor here of Polkadot is the treasury. As you should know that the Blockchain Academy is also funded by the treasury, which is quite remarkable, I would say. The treasury is an on-chain fund that holds DOT token and is governed by all token holders of the network. And those funds come from transactions. So I think there's a small, I think 80, or not small, I think 80% or 70% of every transaction fee goes to the treasury. And slashes, as I said before, but they don't happen very often, right? So the amount of dots that the treasury gets from slashes is almost zero because there are no slashes. And then the main part is, as we discussed a lot before, from staking inefficiencies, which I call them, is basically when the staking rate is not in the ideal situation, not in the ideal staking. And through governance, everybody can submit proposals to initiate treasury spending. I saw that some people, I don't know if they made it here, but also asked for basically scholarships to come here for the PBA, and they had their own treasury proposals. And it currently holds around 43 million DOT. And spending is a little bit incentivized by a burning mechanism, so 1% is burned every 24 days. I just realized we didn't make a break. I'm sorry. You should have said something. It's all right? Okay, sorry guys. So the treasury is basically a DAO, right? A DAO, a decentralized autonomous organization that has access to funds and can make funding decisions directed by the collective that have a vested interest in the network, right? Like token holders have a vested interest because they have tokens, so they ideally only want to make decisions that are smart for the network, which ultimately benefits the network and makes the network more valuable. This has a huge potential that might not yet have been fully recognized by the people, but I feel we're getting there a lot. Like I think, especially in the last 6 months, the treasury has become much more pronounced in the community. And I think it's pretty cool that this provides the chain, the Polkadot chain, the power to fund its own existence and improves the utility in the future. And it will pay core developers to improve the protocol. Some of you know that we have a collective that is called the Polkadot Technical Fellowship that is actually being, at some point in the very near future, being paid by the treasury. And they are being paid to improve the protocol, to work on the protocol, to improve it, to fix bugs, and so on. Also researchers to explore new directions, solve problems, and conduct studies that are beneficial for the network. And I'm quite happy that I'm among those. I got the paper that we published before that I mentioned was actually including an experiment where we ran some experiment with students, and there we actually needed to pay the students some money, and I was fortunate enough to get a little bit of DOT from the treasury for that. For campaigns, educating people about the protocol, which I think is quite popular right now, and also for system parachains, for the development of the system parachains, and for collators. System parachains are basically parachains that are allowed to have a core and they don't need to buy the core. You will see that. So it's kind of a truly decentralized and self-sustaining organization, which I think is quite cool. So how does it all fit together? We have this like little ecosystem, like this little circle of the dot token, that when it increases in value, it increases in security. If it increased in security and value, the relay chain has higher shared security. That kind of grows the ecosystem. It incentivizes the development. This actually makes the block space more useful. It increases the utility of the whole network, which by then has a positive impact on the dot token. And we have this circular thing. So as takeaways, Polkadot is a system that offers shared security and cross-chain messaging. Security scales. It takes less stake to secure 100 parachains than 100 individual chains. The dot token captures the utility that the parachains provide and converts it into security. And the slot mechanism, renewals, or auctions create a market where parachains need to outcompete opportunity costs to be sustainable, so they need to be useful. And as I mentioned before, the new market system does not change the underlying idea here. Cores still have a price, a market price, and whoever buys those cores, at least over time, needs to be useful. Otherwise, they cannot pay the price. Polkadot is a DAO that will be able to fund its own preservation and evolution. And there are many changes to come to the Polkadot ecosystem, creating a much more agile system with like how this is all distributed. Here are some further resources. This is the original RFC from Gav. I linked the discussion on changing the inflation model. There's the talk from Gav about Agile Polkadot. I think that is a blog post on how to select and find good validators. And maybe I should have put in the paper here. But yeah, if you're interested, I can still link that. So, thank you very much for your active participation. If you still have questions, you can come to me. I hope that it all made sense. I think that is the conclusion of the econ module. And yeah, I will be around. Don't hesitate to come to me and to ask some stuff. And yeah, I wish you all the best for the upcoming modules. And I hope you enjoy it. And I'm pretty sure you will enjoy it. And yeah, thank you very much.